Hey, good evening and welcome back to AP Stats Notes Online. We start chapter 3 today, and to get that started, there's this case study. At the beginning of each chapter, there's a case study. We haven't been looking at it. This one's pretty interesting. So the Starnes family, Darren Starnes is one of the authors of the textbook, visited Yellowstone National Park in hopes of seeing the Old Faithful geyser erupt. Right? They only had about 4 hours to spend there. So they pulled into the parking lot near Old Faithful. A large crowd of people was headed back to their cars from the geyser because the Old Faithful had just finished erupting. Okay, so how long would the Starnes family have to wait until the next eruption? Right, and that's a pretty important question to answer, especially if you have a couple of kids, one that's 7 and one that's 4, because if you sit there and wait and it's too long, they start getting antsy and want to run around, and if you come back. If you leave and come back and you miss it, then they're going to start crying and stuff, and that's just not good. So, so you need to try to figure out when it's going to erupt again. So in order to do that, we can grab some data, right, being the wonderful statisticians that we are, and try to figure that out. And so here's a histogram of times between consecutive eruptions of Old Faithful in the month before the Starnes family visited. The shortest interval was 47 minutes, and the longest was 113 minutes. That's a pretty big difference. So the distribution you see here has 2 clear peaks. Here's your bimodal distribution, for those of you that are wondering when we're going to see one. That is what we would call bimodal. One at about 60 minutes and the other at about 90 minutes. So even if you tried to use something like the mode or try to find some sort of median or mean, it's bimodal, but still fairly symmetric. So your mean and your median would fall somewhere in here, and very few times did Old Faithful erupt consecutively in about 70 to 75 minutes. So if you try to go by that, you'll miss it, probably. So the Starnes family hopes for a 60-minute gap between eruptions, but the actual interval is closer to 90 minutes. Like I said before, the kids will get impatient. If they leave and come back, they miss it. Crying ensues, and that's a problem. So what are they going to do? I mean, what are you going to do? And so maybe introducing a second variable here would be useful. And so that's what Chapter 3 is all about. Okay, so we get into the notes. So the first question from your notes, and in this note packet, it will give you an idea of what pages you should be reading in the book, so that you can sort of relate that to the notes that we go through. First question: why do we study relationships between 2 variables? And we just talked about it, right? The reason why is because we want to see if there's a relationship, right? So we want to see if there's a relationship between these 2 variables. That's the question, right? Why do we study relationships? And it's because one variable doesn't give us enough information sometimes. So one variable's distribution doesn't tell the whole story. Okay, so in other words, when's Old Faithful going to erupt again? Well, just using that one variable of intervals between eruptions doesn't tell the whole story. And so we introduce a second variable and try to study that relationship so we can get a clearer picture of what's going on. Okay, well, if you've got 2 variables, one needs to be the explanatory and one needs to be the response. And we've talked about these before already from Chapter 4, which is nice. So the explanatory variable is the variable that influences the other, influences the outcome of the other. Influences the outcome of the response. Okay. The response variable, there's not a ton of space here, is simply a reaction, I guess, to the explanatory would be a good way to say that. Or the response is the outcome of some particular study or of a relationship. Okay? And again, we've talked about these before, which is nice, the explanatory and the response. The bell work from today was taking a look at a relationship between two categorical variables, and we do that in a two-way table with a conditional distribution. So what are we going to do to try to look at a relationship between two quantitative variables? You've heard of these before, but we're going to create scatter plots. Okay, scatter plots are what give us an idea of the relationship between two variables. If there seems to be a relationship, and we'll make that distinction in just a few minutes. So we're going to create a scatter plot. You've done these before, right? A scatter plot is just the x-axis, y-axis, and you're plotting data points that go together, right? So we'll measure two variables on one individual, and then we'll pair those up to create our points for our scatter plot. So which variable are you going to put on which axis? We'll talk a little bit about how that ultimately doesn't really matter, but typically we'll put the explanatory variable on the x-axis, right? So that's a pretty easy way to remember that. And then the response goes on the y-axis. And the response will go on the y-axis. Okay? So being able to differentiate between the explanatory and the response becomes pretty important. So let's try that. Let's try that in a situation here, and this is in the form of your first check your understanding in the book. And so I'll bring that up for you in case you didn't bring your book home with you. That's okay if you didn't. All right, so identify the explanatory and the response. How does drinking beer affect the level of alcohol in our blood? The legal limit for driving in all states is 0.08%. In a study, adult volunteers drank different numbers of cans of beer. 30 minutes later, a police officer measured their blood alcohol levels. Think about that for a second. And then try the second one as well. The National Study Loan Survey provides data on the amount of debt for recent college graduates, their current income, and how stressed they feel about college debt. A sociologist looks at the data with the goal of using amount of debt and income to explain the stress caused by college debt. Now, as you're reading that second one, there are quite a few variables here, and it's entirely possible, and as you get into more advanced statistics, it's exactly what you'll get into, and that is using multiple variables to try to explain or influence one. And so you could possibly have more than one explanatory variable. In our basic level statistics course, we'll only use one explanatory variable, but doesn't mean you can't have more than one, okay? So go ahead, if you want to pause the video and come up with your explanatory and response variables for those two. Again, just making sure that we understand what's driving what and how to plot these out in a scatter plot. Okay, so what'd you come up with? For number one, the drinking beer and the blood alcohol content, your explanatory variable should be the amount of beer, right? And your response should be your blood alcohol content. Okay? And now in the National Student Loan Survey, we need explanatory and response. Your explanatory variable or variables, right, And so it says, a sociologist looks at the data with the goal of using amount of debt and income to explain the stress caused by college debt. And so your explanatory is going to be the amount of debt, and amount of income, and that is used to try to derive or try to drive stress caused by college debt. Okay? And we'll let the sociologist figure out how to measure that, but that's what he or she's going to measure. Okay? So hopefully you came up with those. If there are any problems determining those, we can talk about those in class tomorrow. Okay? So, getting back to our notes, okay? So that's the deal. In our scatter plot, we're going to put the explanatory variable on the x-axis, the response variable on the y-axis. And so we have some data that you collected from in class. And this is the Scrabble deal here. And I'll put this up in case you need to get those in if you didn't get them in before you left class. Okay, so there are, and this is from second period stats class, just to remain consistent. Again, we'll use second period's data and just carry that forward instead of having to go through 3 different scatter plots. Right, and so to create a scatter plot, we would have to determine what drives what. And, well, I'll probably have this backwards now that I look at it, but just the way that the axis was scaled, it made more sense to put the number of letters on the y-axis and the point values on the x-axis. And so point values are going to explain the number of letters in someone's name. I don't know, it might make more sense if the number of letters explain the point values. But again, based on how this was scaled, we actually probably could turn that around and not lose too much in the way of this. Let's do that. Let's turn this around. That's going to make more sense. Okay. And so let's make this number of letters and make this the point values. And if we do that, this could be 5, 10, 20, 30, 40, and then this would become 10, 20, 30, 40. Let's do that. That makes more sense. We might as well make a scatter plot that makes more sense. Okay? So again, go through and create your scatter plot, and it'll be a lot like what you did in the activity for finding out who stole my flag as well. So again, pause the video, make your scatter plot, and we'll compare each other's when we come back. Okay, scatter plot, if you scaled it, your scatter plot the same way I did, should look something like this. At this point, it's probably worth talking about. All of our dots are really close together. Some of these dots represent 3 or 4 individuals. I know 5, 10, there's several right there. So you just obviously can't make another dot, so we just stack them. Sometimes it's worth indicating that there are a certain number of individuals there. So at 5, 10, we've got 1, 2, 3, 4. So you do like an arrow and put 4 individuals there. The other thing we could do is actually zoom in on our data a little bit better. We could scale the x-axis a little bit better. Instead of going by 5s every 2 lines, we could go by 2s every 2 lines down here. And it would be really hard to rescale the y-axis just because we do have that really tall but really high dot there at the 6th student. So, so anyway, that's what we're looking at as far as the scatter plot goes, and this is good enough to get what we want to talk about. Now, number 4 here says describe the association between the number of letters in the last name and Scrabble points. And then it has DOFs in parentheses. Now, what does that mean, DOFs? If I'm going to describe the association between two quantitative variables from a scatter plot, I need to talk about 4 aspects. First, I want to talk about direction. Okay? What's the general direction of our scatter plot? And what we're talking about is positive or negative. And so those are our 2 choices. And so if it's positive, then what we're saying is as x increases, y increases. And of course, in statistics, we always want to add context. So you don't want to just say as x increases, y increases. You want to actually add in the variables there. So, or the direction could be negative, which means that as x increases, y will decrease. Okay, and that's how we want to word this. Is a positive, negative direction. Then we want to add some context. So, and it's always in terms of as the x increases, right? So as we go along the x-axis, what happens to our points? Do they generally tend to go up or go down? And that will give us our direction. F is form. And for our form, we're either going to be linear or not. That's it. Either our dots follow a fairly linear pattern or it's going to be nonlinear. And then our strength is just that. How strong, right? How tight are the dots? How tight together is your data, right? And we talk about strong, moderately weak, and weak. And we'll try to establish some sort of threshold for that later. And so we'll talk about how to describe this guy in just a second. Now, you may be saying, hey, wait a minute, we're missing one. And we are. DOFs has an O in it, so DOFs is kind of like your socks. DOFs is your socks for scatter plots, right? And these are things that you want to make sure that you're talking about when you're asked to describe the association between 2 quantitative variables. And your O here is simply outliers. Okay, are there any outliers? And you guys know what those are. We've talked about those before. Now, there's no sort of numerical calculation for outliers in a scatter plot, not like we have the 1.5 times IQR, creating our buffer zones and whatnot on the ends of Q1 and Q3. So we just had to sort of use our best judgment there. So if we were to describe the association between the number of letters and the last name and Scrabble points, then we would say that the association is positive, because it does seem that as x increases, y is increasing. The association is positive. I would call this thing fairly linear. And strong. Okay, there appears to be one outlier, right? Okay. So what does that mean? It means that as the number of letters increases, so does the point value. And that should make a ton of sense. Okay? So if you're going to describe, you need to include all of that. The last sentence is nice. It just kind of gives you a general idea of the relationship, right? As the number of letters increases, so does the point value. But that's how you want to go about describing the association between your explanatory and response variable for a scatter plot. Okay? And so number 5 gets us into an interesting question, and one that you're going to have to ask yourself as you're finishing up your Who Stole My Flag activity. And that is, does a strong association between two variables indicate a cause and effect relationship? Right? Just because there's a strong association between two variables, is that going to indicate a cause and effect relationship? And as you're thinking to yourself, hopefully your answer is going to be no, right? No, it does not indicate a cause and effect relationship. What do we need for cause and effect relationships, right? There is no treatment applied. So we cannot establish a cause and effect relationship. Okay? Same deal. It's the same deal as before. In that we still have to have, still even a strong association does not indicate a cause and effect relationship. Okay, so we often say in statistics association does not imply causation, and we've talked about this before again from chapter 4, and it follows the same rule. Okay. So there's your scatter plots. How to describe the association, how to interpret a scatter plot. If you're asked to interpret a scatter plot, that's what you want to do. You want to talk about DOFs and where that comes from. I don't want to say because it's kind of silly, but you can see there DOFS is your direction, form, strength, and outliers. Okay, check your understanding on page 149 is where we can wrap up with this. I'll display it for you here, again, in case you did not bring your book home with you. I'll leave this with you, and we can go through that very quickly tomorrow at the beginning of class before you get to your homework. Homework attached to these notes you'll find in the text. And again, as you go through the notes, it'll give you an idea of what pages to read that correlate to these notes. Okay? Enjoy your night. See you guys tomorrow.